Welcome, Algebra learners. Please make yourself comfy, find a piece of paper and a writing utensil, get ready to sprawl out, get that math mind engaged. We're going to be taking some notes today and practicing our inequalities. So as you have that paper and that writing utensil, answer those 3 questions that are there. Pause the video, take the time, write it on your paper. You're going to turn that in as part of your assignment. So just take a moment and answer those 3 questions. All right, remember that a solution to a system of equations is where 2 or more lines meet on any given graph. And the type of solutions that we can have are one solution where they only meet at one spot, no solutions because they never ever meet. That's the saddest love story of them all. Or the happy ending where you have the exact same line and they meet and they are together forever and ever and ever with all those infinite points. The 3 methods that we have for solving those systems of equations is through graphing, substitution, and the elimination. Okay, our opportunity to learn today is that we're going to examine the symbols and the representations of inequalities. And we do that so that we can solve the inequality statements or so that we can isolate y. We'll get more on that tomorrow's lesson. But you can also be heard and ask for help. And the only way that you can be heard is if you ask for help. So in these distance learning opportunities, it's important that you actually come to Zoom meetings and ask for any of those clarifications that you need. Okay, so next on your paper that you have there with your writing utensil, I would love for you to write all of those different symbols down on your paper. And if you're looking at this, we kind of have this separated as 2 different sets of symbols. So you have one on the left side and one on the right side. Go ahead, pause the video, take a moment, write those symbols down, and then write what the meaning for each of them is if you know that. I'm pretty sure you already got that top row of symbols. That's something that you've seen for a while. They're symbols that you've used before. We know that they're less than, greater than, less than or equal to, greater than or equal to, and the only distinguishness, that's not the word I wanted. The only thing that differentiates those 2 is that line underneath. That line underneath makes it that equal to. So we're going to use that same concept for the rest of these symbols. The next line down for the less than or greater than, those open parentheses or that open dot, they really just mean another way of saying less than or greater than. But we use those symbols when we put the answer or the solution on a number line. So again, just to reiterate, those open parentheses or that open circle, they mean less or greater than. So now on the other side, when you have that less than or equal to, you know how we have that equal to sign? It makes sense that you're going to use more lead or you're going to use more ink. And when you have that, that means that you're going to fill in the circle. So you have that closed circle for the less than or equal to, or the greater than or equal to. And also because you have that line, you're going to add that line to the parenthesis, and it makes it be a bracket. So again, those symbols that are less than or equal to or greater than or equal to, they're the brackets or that closed circle. We use that second row of symbols, those parentheses, the open circle, the brackets, and the closed circle. We use those when we graph on just a number line. You'll see that a little bit later. So now this third section, the dashed line or the solid line. The dashed line is when you are actually graphing onto an actual graph. So you're graphing an inequality statement onto an actual coordinate graph, much like we did our lines earlier when we were solving for systems of equations. So if that statement, if that inequality statement has that less than or that greater than symbol, when you graph it, you're going to have that dashed line. And if that inequality statement has the less than or equal to or that greater than or equal to symbol, you're going to graph that on the graph as a solid line. And you will see that in practice tomorrow. So take a moment, make sure that your notes are complete on your paper, and make sure that you can explain them to somebody else, whether that be a pet, or the window, or your mom while she's cooking, or your dad while he's cooking, or your little sibling, or your older sibling, or whoever it is that's around in your house. Take a moment and explain it to them. Tell them the difference of those symbols and what those meanings actually are. Pause the video, go ahead and do that. When you're ready, come back and we'll move on. Okay, so for this slide, we're going to worry just about this top section right here for now. So take a moment, and on your actual paper, I want you to write that x is less than 5 statement, and that 5 is greater than x statement. And I want you to answer, does that actually mean the same thing? Do those two statements mean the same thing? Can you justify that answer that you're giving me? And how would you graph that on a number line? When you're done thinking about that, can you come up with a rule that might work for those two statements? Pause the video, take a moment, write them down, answer those questions, and we'll get right back to it. So it turns out that x is less than 5 means the same thing as 5 is greater than x. And the way we prove that is by putting it on a number line. So we're going to go ahead and create a number line. And that just means you write a line. Clearly, I write them super straight. Yep, that looks like a number line. We're going to go with it. And when we do a number line, what I always like to remember is that we need to have a 0 somewhere on there. We then need to have the number that's represented in that statement. And the number that's represented in this statement is 5, which we know is on that side of the number line. So when we have this, and we're going to graph its solution, is a word we use, or we're going to graph this actual statement, we're going to go back to the rules and the symbols that we learned previously. So that means it's a less than or a greater than symbol, which means that we need to use either parentheses or an open circle. I tend to use the open circles the most. Parentheses you tend to use more in your college years. But right now an open circle works great. So you're going to put an open circle right above that number that is there. So right above the 5 that's represented in both of those statements. And if x is less than 5, that means x can be any value this side of the 5 on a number line. Because we know that 4 is less than 5. We know that negative 3.22227 is less than 5. So it incorporates all of those numbers on the left side of that 5. So if we look at that second one there that says that 5 is greater than x, it also means that same thing, because it's telling us that 5 is the greatest number there on the number line. So all of those x's have to be on that left side of the number line. So now that we have proven that x is less than 5, or that 5 is greater than x means the exact same thing, and we did that on the number line, can you come up with a rule that says that that's true? How would you come up with that rule? Pause the video, take a moment, write down that rule in your words. And then when you come back, I'll tell you how I would explain it. So the way I look at it is this, that x is less than 5 can be read either left to right or right to left. Meaning, I can say that x is less than 5. That would be reading it from left to right. If I were to read it from right to left, I would say that 5 is greater than x. So that rule of thumb is you can read an inequality in either direction. And that's different than how we read in actual English. So it makes it a little bit more tricky in math. But you can read it in either direction. Okay, the next part that we're going to work on is the second half here of that screen. What I would love for you to do is take a moment, write down that 4 is greater than negative 5, and answer, is it true? And then it tells you to multiply both sides by 2, so go ahead and do that. Write the new statement, and then answer if that's true. Continue on with the directions that are there, so multiply both sides by negative 3, divide both sides by negative 1, and answer those questions. Pause the video, take a few moments, see what you come up with. When you're ready, unpause the video, and we'll see what actually happens together. Okay, first of all, 4 is absolutely greater than negative 5. So, yep, that statement is true. So now I multiplied both sides by 2. So 2 times 4, negative 5 times 2. That leaves us with 8 is greater than negative 10. And is that still true? Yes, absolutely. 8 is still greater than negative 10 on a number line. So now it asks us to multiply both sides by negative 3. Let's see what happens. Okay, well, negative 3 times 8 is negative 24. And a negative 10 times negative 3, that negative times negative is a positive. So negative 10 times negative 3 is positive 30. That leaves me with it saying that negative 24 is greater than 30. And is that true? No. That is not a true statement. So what do you think needs to happen to make that statement true? How do you make negative 24 greater than 30 be an actual true statement? The way we do that is by flipping that symbol. If I flip that symbol of that greater than to make it say less than, I now see that that statement is true. It is now asking us to divide both sides by negative 1. And is that still true when we divide both sides by negative 1? Let's see. Well, negative 1 times negative 24, that's that negative times the negative again. So that means that it's positive. And positive 30 times negative 1, well, that would make it negative again. So now we're saying that 24 is less than negative 30. What? Is that still true? No. It's not true. So again, how would you make it true? What would you do to make that statement true? And what you would have to do to make that true is to flip that symbol again. So we'd have to say that 24 is greater than negative 30, which in fact is true. So now that you see that pattern in that exploration, what kind of rule can you come up with there to explain it? Again, go ahead and pause your video, write that rule down. When you're ready, I want you to see how I write it, and you can adjust yours accordingly. So the way I like to phrase that is that when you multiply or divide both sides of an inequality by a negative, then you have to flip the symbol. You have to flip that inequality symbol. And the reason why you have to flip it is to make that statement true. Okay, so now we're going to blend everything that we have learned so far together. Plus, we're going to use what we already know in order to make this happen. So you're going to see this scary word that is your only direction ever, and it just says solve. And I always feel that that's like the hardest direction because you just don't know what they're asking for. They just say solve, and you're like, solve for what? What am I doing? But in reality, you're just going to solve for whatever variable is there. And then in inequalities, you always have to graph that solution on a number line. So we're going to do this first one together, and then I'll have